Hello. So, in this video, we are going to be introducing the idea of the piecewise function, in particular, the sort of geometric meaning or what it's sort of used for or how to think about these things geometrically. So, by way of example, let's say that we want to model some number of people that are sort of been caught ill or diseased in some what we would call susceptibility models. This is like a classic thing done in you know, tracking diseases through populations and trying to find outbreaks and stuff like that, okay? So over time, if we're looking at the number of infected, well, initially, right, when nobody knows there's a disease, infection tends to go sort of pretty quickly, right? You have some sort of starting spot, and then it sort of explodes out exponentially because the more people that get infected, the more people those people can infect, right? It's literally exponential growth. But at some point, people become aware of the sort of outbreak, epidemic, pandemic, whatever it is, and places start instituting, right, some sort of countermeasures, be it social distancing or being sort of proactive with antibiotics or whatever needs to happen. And so after some period of time, the amount of people getting sick might still increase, but it sort of very quickly has this transition point where it starts actually decreasing the amount of or say the speed at which people are getting infected, okay? So we have this sort of weird situation where there is a key moment, right, some time t, where the fundamental nature of what's happening shifts, right? Those actions have been taken and it actually sort of impacts the amount of people being infected, and so it no longer is following the same trend. So the problem then is there isn't one parent function, right? There isn't one thing dictating this. There's some stuff about like logistics curve models and it has to do with how like resources can sort of support things. And this is a whole other conversation for those that are sort of interested in modeling. There are some ways of sort of modeling very specific types of things loosely, but even those don't sort of account for the idea that actions happen partway through that shift how the behavior is being sort of modeled partway through the time period. So here, right, instituting sort of countermeasures is this fundamental step that changes how it behaves, and as a result, we don't have one parent function. So what do we do about that sort of situation? What do we do when we have not one parent function, but maybe 2 or 3 or 4 different behaviors that are occurring? Well, if we want to sort of make this thing a function, right, we want to say this is f of t, we need some way of gluing together these different parent functions, the different sort of moments, right, the pre-action taken and post-action taken sort of representative models. And to do that, that's where this piecewise idea comes in. So we might have, in this case, 2 functions, right? We have the function that happens beforehand, before we've taken any steps, this g of t part. And then we might have this other part, this h of t, that happens sort of after these countermeasures have been sort of deployed or starting to be used. And we would want to take those 2 things, this h of t and this g of t, and sort of glue them together somehow to get our overall f of t. All right, so our f of t, the model, the function that represents the whole time period, it's really just taking g of t and h of t and somehow, quote unquote, gluing these things together. And what we mean by that is that g of t is really taking place between 0 and whatever this time was, right? This t, this moment where we started doing something. And then h of t is the sort of after effect. It goes from that time t up until we are sort of done modeling this f, okay? So this is the sort of geometric idea of a piecewise function. A piecewise function sort of at its core is this idea of gluing together different functions, of taking different behaviors that apply in different sort of sections of the graph and sort of sticking them together in some way that we're calling a function, okay? The actual mechanics of doing this is a little more tricky, which is why we're going to do that in a separate video, but this is the sort of picture that you want to have in mind whenever you're really thinking about piecewise functions. The whole point of a piecewise function is it isn't really a function, it's several functions sort of being mashed together, okay? All right, so what do? Well, we talked about the geometric interpretation or the visual of piecewise functions, right? This idea of smashing stuff together and calling it one function, right? When we have situations where it doesn't really have a function that represents it, instead it has sort of a sequence of functions that are like, you did it this way for a little while, and then it turned into this other thing, and then maybe it turns into this other thing, and we want to be able to represent that over the whole time period or the whole set of values. And so we do that by using these piecewise function. Again, the term's a little misleading because it's not a function so much as it's a single way of writing these different functions, sort of each being done in their own little areas, smashed together into one thing. Okay? All right. So that is that.